In this problem, Alice and Bob play n games of rock, paper, scissors, and we know the number of times Alice and Bob play rock, paper, and scissors. And from these numbers, we want to find out the minimum number of rounds Alice can win and the maximum number of rounds Alice can win. So, due to an audio issue, I just solved this, but the audio got cut. So I'll just go over how to solve it. So let's look at the very last test case, right? Uh, this is rock, this is scissors, this is paper. So this number tells us the number of times Alice will play rock, the amount of times she'll play scissors, and then the amount of times she'll play paper. And these are the same values for Bob. So to find the maximum number of times that she can win, that occurs when she plays rock and Bob plays scissors, or when she plays scissors and Bob plays paper, or when she plays paper and Bob plays rock. So when is that? So when she plays rock, she wants her opponent to play S, right? So it'll always be the minimum of 10 and 103 in this case, right? Because if there are because after she uses all 10 of her rocks, she can no longer play rock, so she has to use something else. So it's always the min of all the winning conditions, and the winning conditions would be if Alice plays rock and Bob plays scissors, if Alice plays scissors and Bob plays paper, oops, and if Alice plays paper and Bob plays rock. Whoops. Yeah, Alice plays paper and Bob plays rock. So we just find the min of each of these pairs and then we sum them all up, and that's the maximum number of times she can win. So it's very straightforward to find the min number of rounds, that's the max number of rounds. You can find a bit more complex, like min max statement to find the min number of rounds that Alice can win, but a much nicer way to do this is through min max flow. So let's just focus on again this last example. How do we know that it's 119 is the least amount of games she can win? Okay, so let's open this. So this is so this is the global source node. This is the global sink, and these nodes indicate that here Alice plays rock, Alice plays scissors, Alice plays paper, Bob plays rock, Bob plays scissors, and Bob plays paper. So we just need to now figure out how to link these intermediate edges, right? So what we do is, okay, since we're trying to find max flow and we're trying to find the min number of games that Alice could win, let's make this into a problem with the max of something. So let's find out the max number of games that Bob can't lose, right? Because if Bob can't lose, that means Alice won't win. So for Bob to not lose, either Alice and Bob play the exact same element, or for example, if Alice plays rock, then Bob plays S. So this would be that edge. So this edge would indicate that they both play paper, they both play scissors, they both play rock. This would indicate that Bob played paper, whereas Alice played rock. So in this case, Bob would win. Here, Bob would not lose. Now the weights on the edges. So this weight is going to be the amount of times Alice plays rock, and then this edge would be the amount of have the capacity all the way until the amount of times Alice can play S, and so on and so forth. And then once we reach this stage, we have use all the constraints, and we just want to sum up these values. So we just want to ensure that the weights on these three edges are large enough so that they don't reduce any of the weights, any of the flows that reach RB, SB, or PB. Those set it to a really big number. So then by finding this, we'll find the highest number of games that Bob cannot lose. And since we know that the total number of games here is 319, we can just do 319 minus the answer we get from this max flow problem, and that will be the minimum number of games that Alice wins. So the max flow algo that was used here was Phoenix algorithm, which has O of v squared e time complexity, which would be more than fast enough because there's only eight nodes here. So this implementation, I think, is from the Stanford ACM repository. So I just nabbed it up there, and then yeah, so to find the max with just a min of all the winning combinations, then you create this object, you add the edges, you find the flow, and then you subtract that answer from the number of games that they both play. And that's how you get min, you have max, and then we output that. And this does indeed work. So voila.